Will the universe last forever? The words slip easily off the tongue, but they carry a weight that can bend the mind. If forever is real, then we live inside an endless stage where the play never ends. If forever is not real, then all of this, the stars, the galaxies, even time itself, must one day vanish into silence. Both answers are unsettling, both are possible. You feel it, don't you? That tension between the comfort of permanence and the terror of impermanence. Forever is reassuring when you whisper it to yourself in the dark, but also haunting when you realize what it implies. Eternity means no exit, no conclusion, no resolution. A stage light that never dims, a story that drags endlessly on. But impermanence is a different kind of weight. It means that everything you know is balanced on borrowed time. That even the universe itself, vast and powerful as it seems, might have an expiration date written into its fabric. So you hover between two infinities, an infinity of endless time or an infinity of eventual nothing. Both stretch your imagination until it begins to fray at the edges. Look up at the night sky in your mind. Thousands of stars scattered like salt across black velvet. They appear steady, timeless, eternal. You can look at them tonight, tomorrow, a year from now, and they will seem unchanged. But this is an illusion of scale. Those stars are not immortal. They are burning, exhausting themselves, pouring their fuel into the void until one day they collapse, explode, or fade. What looks eternal to you is only a brief flicker on cosmic time. And so the question deepens. If even stars can die, what about the universe itself? Could the whole cosmic stage one day collapse, fade, or end? Or is the universe different, so vast, so fundamental that it cannot share the same fate as its pieces? The weight of the question lies not just in physics, but in meaning. If the universe lasts forever, then everything we do is swallowed by eternity. The victories and failures, the moments of love, the struggles, the discoveries, what are they against an endless backdrop? Perhaps they matter more because they become eternal threads woven into infinity, or perhaps they matter less because nothing can stand out against an endless canvas. And if the universe does not last forever, if one day all of this dissolves into a kind of cosmic silence, then every moment is sharpened with urgency. It matters not because it lasts, but because it doesn't, because it is fleeting, because it will never come again. You feel the dilemma turning in your mind, pressing from both sides. To live in an eternal universe is to live without end. To live in a finite universe is to live with the shadow of an end. Neither feels comfortable, and perhaps that is the secret heartbeat of the question. It is not only about the universe, it is about you, about us. We are temporary beings made of stardust, destined to dissolve back into the fabric from which we came. The question of the universe's fate is, in some hidden way, the question of our own fate writ large. Imagine the universe as a great stage. On it, galaxies whirl like dancers, stars flare like spotlights, planets spin like props in an elaborate play. You and I, tiny, fragile, step briefly onto that stage, speak our lines, and then exit. But the deeper question is whether the stage itself endures after we leave. Will it stand empty but intact, waiting for new players in some endless cycle? Or will it too collapse, the boards rotting, the curtains falling, until there is nothing left but silence? It is a question that stretches far beyond science and into philosophy, into poetry, into the deepest corners of human thought. Because forever is not just a measurement of time, it is a test of imagination. Can you even picture forever? Can you feel it? Not just say the word, but actually let your mind sit in that endlessness. Try it now. Imagine time stretching forward without end. Years flowing into centuries, centuries into millennia, millennia into eons, eons into something beyond names. Try to find the edge. Try to picture the moment where it stops. You can't. Your mind begins to recoil, to resist. It's like staring at a horizon that keeps running away from you, always just out of reach. Now imagine the opposite. Imagine an ending. Imagine a moment far, far ahead when the stars have burned out, when galaxies have grown cold, when even atoms themselves have decayed into nothing. Try to feel the silence of that final moment when there is no one left to see, no one left to know. It feels alien, unbearable, as though the universe itself is holding its breath and never exhaling. Forever or not forever, eternal stage or final silence, both leave you unsettled. Both force you to confront the strange, fragile miracle of existing right now in this thin sliver between what has been and what might be. Perhaps that is why the question matters so much. It is not idle speculation, not abstract theory. It is a mirror. When you ask if the universe will last forever, you are also asking, what does it mean that I am here? What does it mean that anything is here at all? Science will try to answer, of course. Equations will be written, theories proposed, evidence collected from the faint afterglow of the Big Bang, from the motion of galaxies, from the fate of stars. But the heart of the question will never be purely scientific. It will always carry the echo of human wonder, human fear, human longing. So we begin here with this weight in your chest. The stars above you seem steady, but you know better now. They are temporary like you. The universe itself may share that same fate, or it may not. Both possibilities are open. Both stretch ahead like paths into a dark forest where you cannot yet see where they laid. And maybe, as you rest here with the question, you realize something. The act of wondering is itself part of the answer. To be the kind of being who asks whether the universe will last forever is to stand on the knife edge of awareness, fragile and fleeting, yet connected to something unimaginably vast. The question remains hanging in the dark. Will the universe last forever? And the silence that follows is not empty. It is full of possibility. You sit with the question like a stone in your hand. Will the universe last forever? It is not the kind of question you can answer quickly or tuck away neatly with a few words. It lingers, it spreads, it pulls threads in every direction, because hidden inside it is not only the fate of stars, galaxies, and time itself, but also the fate of meaning, the weight we give to our lives, our choices, our very breath. The strange thing is that the universe does not look like something that would end. When you gaze upward, the stars do not seem fragile. They are not like candle flames flickering in the wind. They blaze, they burn with a violence so immense that it feels beyond destruction. The sheer size of it all, the Milky Way stretching across the sky, the knowledge that there are billions of other galaxies seems to whisper permanence. How could something so vast, so unstoppable, ever collapse into nothing? And yet the illusion of scale is tricky. You have felt it before in your own life. A mountain looks eternal until you learn how rivers carve valleys through stone, grain by grain, drop by drop. A city looks permanent until you remember how quickly time erases buildings, roads, and names. A memory feels everlasting until you notice how it frays at the edges, fades with each passing year. Nothing you have ever touched, nothing you have ever seen has lasted forever. Why should the universe be any different? Here your intuition stumbles. Because the universe is not like the things within it. It is not an object in a larger container. It is the container itself, the stage on which everything else appears and disappears. And so the question becomes slippery. When you ask if the universe will last forever, what are you really asking? Do you mean the stars, the galaxies, the material things we can see and measure? Or do you mean space and time themselves, the very framework in which those things exist? Because stars are mortal, galaxies are mortal, even black holes, the strangest and most enduring objects we know of, will eventually fade. But the universe as a whole, that is a harder thing to picture ending. Harder, but not impossible. You let your mind drift further, letting the weight of the question expand. Imagine billions of years from now, stars running out of fuel, the night sky no longer glittering but dim, scattered with corpses of suns, planets frozen, lifeless, galaxies drifting apart, pulled by the stretching of space. The warmth of creation slowly bleeding away into cold emptiness. It sounds bleak, doesn't it? Like a fire burning out in slow motion. And yet there is a strange calm in that vision too. A cosmic silence, vast and unbroken. But then imagine the other side, the vision of eternity. Imagine a universe that never ends. Galaxies spinning forever, time rolling forward without boundary, no final silence, no collapse, just endless unfolding, infinite variations, infinite futures. That should feel comforting. And yet eternity has its own terror. Because what does it mean to live inside a story that never ends, a cycle that never stops turning? Here you might notice your thoughts begin to loop. Ending is frightening, but so is never-ending. Both stretch your imagination beyond its comfort zone. You cannot quite imagine nothingness, and you cannot quite imagine eternity. It is like trying to stare directly into the sun. Your mind flinches, turns away, cannot hold the full weight of it. So you fall back on metaphors, on images that try to give shape to the unimaginable. You picture the universe as a fire. Fires burn out, their fuel is consumed, their light fades, their warmth dies. That makes sense. But maybe the universe is not a fire. Maybe it is a river, always flowing, always moving forward, never running dry. That image makes sense too. Which is true, fire or river, ending or endless? The unsettling truth is that both metaphors feel right and wrong at the same time, which is why the question of forever refuses to leave you alone. And there is another layer, one you may not have noticed yet. When you ask about the universe lasting forever, you are not really asking about the universe. You are asking about yourself, about the fragility you carry inside you every day. You know you are temporary, you know your time is short. So you look up at the sky and ask whether the thing that holds you, the thing that birthed you, will outlast you, or whether it too is marked for death. This is the heart of it. If the universe ends, then nothing lasts. If the universe is eternal, then perhaps in some strange way you are part of that eternity. Perhaps the atoms in your body, the dust of old stars, will go on forever in some form, recycled endlessly in the great cosmic dance. But if the universe does not last, if there is a true ending, then even the atoms will one day dissolve into nothing. It is dizzying, it is beautiful, it is terrifying. And it is exactly the kind of thought that makes you feel both infinitely small and strangely vast at the same time. Pause here, breathe with it. Notice the sensation in your chest as you consider both outcomes. You are alive in this brief flicker of time, asking questions that stretch beyond time. That in itself is extraordinary. You might find a kind of peace in the not knowing, because the truth is you are not meant to have the answer yet. The question is not a puzzle to be solved in one sitting. It is more like a horizon, always moving just beyond your reach. Every step toward it opens new possibilities, new mysteries. That is the nature of forever. So for now, you stand between two visions, an ending and an endlessness. Both are equally real in your imagination. Both are equally haunting. Both contain their own strange beauty. But the question remains, pulsing like a star at the edge of your thoughts. What does science say? The theories are there. The evidence is out there, written in the faint light of distant galaxies, in the afterglow of the Big Bang, in the equations that describe how space itself bends and stretches. Soon you will look at those theories. Soon you will ask whether the universe expands forever, collapses into itself, or fades into silence. But not yet, not here. For now, you simply rest with the weight of the question, turning it in your mind like a stone smoothed by water. Will the universe last forever? You do not know, you cannot know, and maybe that is the point. The question itself becomes a kind of meditation, a doorway into wonder, a reminder that to exist at all, to be capable of asking such a thing, is already miraculous. So you hold the question, fragile and infinite, as the night stretches silently around you. The question lingers in the silence around you. Will the universe last forever? To even ask it is to admit something almost more astonishing. The universe had a beginning. A forever stretches only in one direction unless you imagine it without a starting point. But we know the universe has a story, and every story begins somewhere. The story of the universe begins with a moment we call the Big Bang. A phrase too small for what it describes, a metaphor stretched across something we cannot truly picture, because it wasn't an explosion in space. It was the creation of space itself. It wasn't matter flinging outward into an empty void. It was the void itself being written into existence, stitched together moment by moment, expanding into being. Try to picture it, not just light, not just fire, not just chaos, but the birth of time itself, a moment before which there were no moments, the instant in which space, time, energy, and matter, everything emerged. You might imagine a blinding flash, a roar of creation, but the truth is subtler. The Big Bang wasn't a firecracker going off into silence. It was more like a deep breath being taken, a swelling that has never stopped. From that first instant until now, the universe has been expanding, stretching, cooling, evolving. And if the universe had a beginning, then we must ask, does it also have an end? Beginnings imply endings. That's how our lives work. That's how everything you've ever touched works. You are born, you live, you die. A song starts, it rises, it fades. A fire is lit, it burns, it goes out. Why should the universe be different? But here intuition falters again, because the universe is not simply another thing inside of time. It is time. It is not simply another object moving through space. It is space. To say it had a beginning is already difficult enough to imagine. To say it might have an ending, an actual moment of non-existence, is even stranger. Pause here, consider what it means that time itself might end. Not just the end of human civilization, not just the fading of stars, but the end of time as a dimension, the end of before and after, the cessation of sequence, a silence beyond silence. And yet when scientists trace the story of the universe forward, they cannot avoid it. The equations demand it. The evidence points toward it. The future of the universe is written, at least in probabilities, in the way galaxies move, in the temperature of empty space, in the strange energy that seems to push everything apart. But before the end, there is the middle, and you are in it now. Think about this: you live in a universe that is still young. 13.8 billion years may sound like an unfathomable span, but in cosmic terms, it is the first act of a very long play. Stars are still forming, galaxies are still clustering, black holes are still devouring suns. Creation is still unfolding around you in real time. You are alive during a window when the night sky is rich with starlight, when galaxies are visible, when life is possible. It won't always be so. Far ahead in time, the stars will fade, galaxies will thin out, the sky will grow darker, the universe will look emptier. One day there may be no visible evidence of the Big Bang left at all, no galaxies beyond the local cluster, no cosmic microwave background, no hint of the universe's fiery birth. Future beings, if any survive that long, might look into the sky and see nothing but darkness. They might never know they live in a universe that began with a bang. And so, when you ask if the universe will last forever, you are really asking about trajectories. Will this expansion go on eternally, thinning into emptiness without end? Or will something pull it back together, collapsing everything into a final implosion? Or is there a stranger fate, one where time itself changes shape in ways we cannot yet imagine? The strange thing is that you already know pieces of the answer. You can feel it in the night sky. The universe is expanding, galaxies are receding, space itself is stretching. This is not guesswork, it is observation. The light from distant galaxies carries the fingerprint of motion. Redshift, proof that space is growing larger every second. Proof that the universe is not static but restless, dynamic, unfinished. So the real question becomes, does that expansion stop? If gravity is strong enough, perhaps expansion will slow, halt, reverse. A great cosmic inhalation followed by an exhalation. A universe that ends where it began, collapsing into fire and density, a mirror of the Big Bang, a big crunch. Or perhaps expansion is unstoppable. Perhaps dark energy, that mysterious force stretching space apart, will continue to accelerate the motion, driving galaxies farther and farther until they vanish from sight, until stars burn out, until even atoms themselves are torn apart. A big freeze or a heat death. And there is yet another possibility. A big rip, where the acceleration becomes so extreme that even space-time itself cannot hold. Seas ripped apart, stars ripped apart, planets, molecules, atoms, everything undone by expansion. Each possibility is a kind of ending, some violent, some quiet, but all unsettling. Still, pause here and notice something. The universe is not only about endings, it is about the present, the moment you are in now. You exist in the middle of this great unfolding. The atoms in your body were forged in stars that burned and died long before the Earth was born. You are made of endings, and yet here you are alive, breathing, asking about forever. Perhaps this is what matters most, that you can wonder, that you can imagine billions of years into the future and billions into the past, that you can stand at the edge of mystery and feel both terror and awe. Because whether the universe lasts forever or not, your asking ties you to it. You are not separate from the universe's fate. You are part of it, a fleeting note in its great, unfinished song. And so the question deepens again, is forever even the right way to think about it? Maybe forever is too human a word. Maybe the universe doesn't fit into our categories of ending and unending. Maybe it moves on a scale of being that we cannot yet grasp. Still, you return to the question because it refuses to let go. Will the universe last forever? The answer waits in evidence, in physics, in the subtle clues left in starlight and background radiation. Soon, you will follow those clues into the broken intuitions and strange discoveries of modern cosmology. But for now, you rest again in the middle. The universe is here, you are here, and for this moment that is enough. The story continues. You've carried the word forever since childhood. It sounded so simple back then, like a promise. You said it in whispers to friends, to family, to the people you loved. Forever. It meant never letting go, never running out, never ending. But when you stretch that word across the universe, it begins to break, because intuition tells you that forever is easy. If something lasts a long time, you just extend it further and further still. A candle burns out, but imagine a bigger candle. A mountain erodes, but imagine a mountain larger than any river could carve. Surely the universe, being the largest thing of all, is too big to end. Surely it is immune to the small, fragile rules of ordinary life. But here intuition betrays you. The universe is not simply a larger version of the things you know. It does not obey your instincts. In fact, the more we have studied it, the more it has defied expectation. Think of what the night sky once looked like to ancient eyes. Eternal, unchanging, stars fixed in their places, circling like clockwork. The cosmos seemed steady, reliable, infinite. That was the intuition of generations, but it was wrong. Stars are not fixed. They are born, they live, they die. The heavens are not a stage set, but a battlefield of fire and collapse. And not only that, space itself is not stable. For most of human history, we assumed the universe was eternal, unchanging, infinite in age as well as size. How could it be otherwise? Look upward and nothing seems to alter. Intuition said, this has always been here and always will be. Then came the evidence, galaxies moving apart, the echo of a beginning in the microwave background, the discovery that time itself has a starting line. Suddenly intuition collapsed. The universe is not eternal in the past. It has an age, a birthday, a moment of creation. And if the past can surprise us, why not the future? You see, intuition tells you that time is a straight line, unbroken, stretching endlessly in both directions. But physics does not guarantee that. Time could curve, it could collapse, it could even tear apart. The rules that govern everyday life, apples falling, clocks ticking, cannot simply be scaled up to the size of the cosmos. At the largest scales, the universe plays by different rules. Take expansion, for example. You might imagine galaxies flying apart through empty space like shrapnel from an explosion. That's what intuition suggests, but it isn't right. Galaxies are not moving through space. Space itself is stretching, carrying them with it. The distance grows not because galaxies race like arrows, but because the fabric between them swells. And here's the strange part, that swelling has no edge, no boundary, no outside. Expansion happens everywhere at once. The universe doesn't expand into something else. It just expands. That defies the senses. How can something grow without pushing into anything? How can distances increase if nothing moves? Intuition stumbles again and again. And now the greatest blow, the discovery of dark energy. You would think, wouldn't you, that gravity, the great pull of all masses, would slow the universe's expansion over time? That makes sense. It is what you've seen everywhere else. Throw a ball into the air and gravity slows it down. A firework explodes and the fragments scatter, but gravity tugs them back to Earth. Intuition says the same must be true for the universe. Expansion should slow, eventually stall, maybe reverse. But no, the opposite is happening. Expansion is not slowing, it is speeding up. Galaxies are not merely drifting apart, they are accelerating away from each other. Something unseen is driving them apart faster and faster. This is not just a small correction to intuition. It is a fracture, a contradiction. Expansion does not behave like anything in daily life, and the energy behind it, dark energy, is not only strange, it is dominant. 70% of the universe is made of it. 70% of reality is something we do not understand, something that makes forever look very different from what your instincts tell you. Pause here, feel the ground shift under your thoughts. You wanted forever to be simple, a line drawn to infinity. Instead, you find forever is fragile, unstable, uncertain. Even the idea of ending begins to fracture. What does it mean for the universe to end? Does it vanish instantly like a candle snuffed out? Does it fade slowly like smoke thinning into air? Does it collapse violently like a building imploding? Each picture feels intuitive and each may be wrong. The actual fates science describes, heat death, big rip, eternal expansion, are not images your senses can easily grasp. So you must let go of intuition. You must allow yourself to stand in the discomfort of not knowing, of not being able to lean on instinct. This is the threshold where science begins, not with certainty, but with broken expectations. Think again of that word, forever. In your mind it has always carried a sense of comfort, even romance. A forever love, a forever home. But in the cosmos, forever has no guarantee of comfort. Forever might mean an eternity of emptiness, a universe stretched so thin that nothing remains. Forever might mean an eternity of collapse, a fire that consumes even the ashes. And forever might not exist at all. It is here, in this breaking of intuition, that you glimpse the strangeness of reality. That the universe, vast and indifferent, does not bend to human imagination. That forever is not a promise but a question, and the answer is written in mathematics, in starlight, in the faint whispers of energy we cannot see. So you stand now at a crossroads. Behind you lies the comfort of intuition, stars eternal, time unbroken, forever as a simple word. Ahead of you lies something stranger, a universe that does not obey instinct, a universe whose forever may look nothing like the forever you first imagined. You may feel unease here, that is natural. Every great question in science begins by breaking the illusions we hold. The Earth is not the center of the cosmos. Matter is not solid but mostly empty space. Time is not absolute but bends and stretches with gravity. And now one more, forever is not simple, forever is not safe. This brokenness is not the end of the story. It is the beginning. Because only by breaking intuition can you start to rebuild it into something stronger, stranger, and truer. The universe does not care what you find comfortable, but it offers you something greater than comfort, wonder. And so the question deepens again. Will the universe last forever, or will it end in ways no instinct can predict? The answer waits, hidden in the structure of galaxies, in the faint afterglow of creation, in the mathematics of expansion. The clues are there. But first you must learn to let go of your old forever so that a new forever can emerge. Your intuition breaks further when you turn to one of the simplest, most universal laws we know. A law that does not care about galaxies or black holes or cosmic scale. A law that rules every flicker of a flame, every melting ice cube, every breath you take. The second law of thermodynamics, entropy. The word sounds technical, but its meaning is intimate. It is the law of disorder, of change, of the one-way flow of time. It says simply this: in any closed system, disorder tends to increase. Energy spreads out, differences even out. Hot and cold mix into warm, order dissolves into chaos. You have seen it everywhere. A cup slips, shatters into pieces. The reverse never happens. Smoke rises and disperses, never returning to the match. Ice melts into water, never spontaneously freezing itself back into a perfect cube. Entropy is the reason time has direction. It is the reason you remember the past but not the future. It is the arrow that points forward, the silent current carrying everything with it. Now extend this law to the universe. If everything tends toward disorder, if energy always spreads, then what does forever really mean? It means a slow unraveling. A long evening where the fire dims, the warmth fades, and nothing is left but cold balance. Imagine it. At first the universe is young, filled with fire, filled with stars burning bright. Order exists because energy is unevenly distributed, hot here, cold there, dense in one region, sparse in another. That imbalance is what allows stars to shine, planets to form, life to emerge. But entropy insists imbalance cannot last. Over time, energy spreads out. Stars exhaust their fuel. Galaxies grow thin. Everything drifts toward equilibrium. The universe, then, is not a permanent engine. It is a one-time flare of usable energy. And when that energy evens out, when entropy reaches its maximum, the universe enters its final state. A state with no heat differences, no structure, no possibility for work. A state called heat death. Pause, feel the weight of that phrase, heat death. It does not mean sudden collapse, not a fire consuming everything at once. It means stillness, a silence spread across eternity. Every star burned out, every planet frozen, every black hole evaporated. Matter itself decayed into scattered particles, drifting endlessly in an expanding void. A universe not dead by violence but by exhaustion. Here intuition shatters completely, because you might think of forever as infinite possibility, infinite time to build, to grow, to continue. But entropy says otherwise. Forever does not mean endless creation. It means endless decline, an inevitability written into the laws of thermodynamics. This is unsettling, isn't it? The idea that the universe, vast as it is, carries inside it the seed of its own exhaustion, that no matter how far you stretch time, the outcome is the same, stillness, a flat line written across eternity. And yet there is a strange beauty in it too. Entropy does not destroy meaning, it shapes it, because it is entropy that allows stars to burn in the first place. It is entropy that drives the flow of energy, that fuels life, that creates the temporary structures we marvel at. Without entropy, there would be no story to tell, no change, no growth, no moment like this one. So forever, through the lens of entropy, is not the promise of infinite continuation. It is the slow, inevitable drift toward balance, toward silence, toward a universe at rest. But wait, rest is not quite the right word. Rest implies peace, a kind of completeness. The heat death of the universe is not peace. It is emptiness stretched too far to imagine, a forever so vast and barren that even the word forever begins to lose its meaning. Try to imagine it, not 10 years, not 1,000, not even 1,000,000,000. Imagine time so extended that even black holes, the most enduring structures we know, have dissolved into radiation. A time when nothing remains but thin clouds of particles scattered across a universe stretched beyond recognition. A time when even memory itself has no place to cling. It is not simply death, it is erasure. Your intuition cannot hold this vision easily. Because you live in a world of cycles, day and night, life and death, seasons turning, you expect renewal, you expect return. But the universe, in its deepest law, does not promise renewal, it promises entropy. And here the idea of forever becomes something colder, stranger. Not endless story, not endless cycle, but endless quiet. But pause again, do not let dread take over. Notice instead the miracle of this moment. The fact that you live now in the brief era when stars still burn, when galaxies still shine, when life is still possible. You exist in the universe's rare window of brightness, a fragile candle against the endless dark. What does that make you feel? Fear, awe, gratitude, perhaps all at once? Because if entropy rules, then your life is not meaningless. It is luminous, a spark against the backdrop of inevitability, a defiance, however temporary, against silence. This broken intuition, the realization that forever is not endless growth but endless decline, does not erase wonder, it sharpens it. It reminds you that every breath, every moment, every glimpse of starlight is part of the fleeting miracle of low entropy, a miracle that will not last forever, a miracle that makes now precious. And so the question sharpens once again, will the universe last forever? If entropy is correct, the answer is yes and no. Yes, the universe may persist without end, but no, it will not remain alive, not remain vibrant, not remain capable of newness. It will continue, but in silence, forever not as promise, but as emptiness. This is not the forever your childhood imagined. It is not comfort, it is not romance, it is physics. But physics has a way of surprising us. For all its inevitability, entropy may not be the only story. Dark energy, quantum fluctuations, possibilities we have not yet imagined, they all whisper that the universe may hold more secrets, that perhaps the second law, while inescapable, is not the full picture of eternity. And so your intuition breaks again. Forever is not what you thought it was. Forever is stranger, forever is darker, forever is uncertain. You rest with this unease, letting it settle in you, because it is here in broken intuition that wonder is born. The universe may last forever, or it may not, but either way it will not look like anything your instincts once promised you. The story continues, and it is far from finished. You have lived your whole life with a single assumption, so deep you hardly notice it. That time is steady, that it flows like a river, smooth and constant, that 1 second is always just 1 second, no matter where you are, no matter what you do. But that is an illusion. Time does not tick evenly like a perfect metronome. Time bends, time stretches, time slows down, time speeds up. Time is not the universal stage on which events unfold. It is part of the play itself, warped and shaped by the actors within it. Einstein showed us this in a revelation so shocking that it shattered centuries of certainty. The clocks we carry are not absolute. They change depending on how we move, on how close we are to massive objects. A second for you may not be a second for someone else. The flow of time itself is relative. A pause here, let that sink in. Because it means that your most basic intuition, that time is eternal and uniform, cannot be trusted. Time is elastic, time is fragile, and if it can bend, it can also break. Imagine two twins. One stays on Earth, the other travels near the speed of light. When they reunite, the traveling twin is younger. The one who stayed has aged more. Both lived through their own seconds, both counted their own heartbeats. Yet their experiences of time are not the same. Time itself changed for them. This is not science fiction. It is reality. We have measured it. Astronauts, GPS satellites, even particles in accelerators all confirm it. Time is not fixed. It is a dimension woven into space, and the fabric of that space can twist. Now stretch this realization to the universe. If time is part of space and space itself is expanding, then time is expanding too. The clock of the cosmos is not steady. It ticks according to the fabric it belongs to. And if space can have a beginning and possibly an end, then time must as well. This is the broken intuition you must face. Time is not eternal. Think about what that means. You have always imagined forever as endless time, but if time itself has boundaries, then forever may not exist. There may be no such thing as always or never, only spans within the container of time. Consider again the Big Bang, not just the beginning of matter and energy, but the beginning of time itself. Asking what was before is meaningless because before did not exist. The stage itself had not been built. The curtain had not risen. There was no before. And if there was no before, then perhaps there will be no after. Perhaps the story of time is not infinite but finite. A line with two ends, not a line stretched endlessly. A burst of duration, bounded on both sides by nothingness. Your intuition resists this. It insists that time must extend beyond all boundaries. But that insistence is born of human experience. You know beginnings and endings only within the frame of time itself. You cannot easily imagine the absence of time because imagination itself requires sequence. Thought requires before and after. Without time, even the idea of without time begins to dissolve. So you are left with paradox. You can picture eternity only by picturing endless time. But if time itself is not endless, then eternity is not what you thought. And here, the word forever begins to lose its grip. What if the universe does not last forever because forever does not exist? What if time is finite and all things, including the cosmos, are caught inside its flow? This idea bends your intuition until it cracks. Because if time is finite, then the universe is not just a story with a beginning and end. It is the only story. There is nothing outside it, no before, no after, just the arc itself contained within its own horizon. Pause, let that unease wash over you. Because this is where the mind rebels. We are creatures of time. We cannot step outside it. Our entire experience of reality is measured in the rhythm of moments. To imagine its end is to imagine the end of imagination itself, the end of awareness, the end of asking questions. And yet the physics insists. Time is not immune. It is part of the universe. And what belongs to the universe cannot last longer than the universe itself. Now consider the strange twist this introduces to your original question. When you ask if the universe will last forever, you are using a word, forever, that may not apply. It is like asking how far the edge of the Earth goes when Earth is round. The question carries a flaw in its shape. Maybe the universe cannot last forever because forever is not real. You might feel the ground fall away here. The familiar anchors of beginning and end, past and future dissolve. You are left floating in something harder to name, a story that may not have an always, only a was and a will not be. And yet don't rush to despair, because there is another side to this. If time is finite, then every moment inside it is infinite in value. There is no endless stretch to dilute meaning. There is only the singular miracle of existence, the unrepeatable sequence of now. This, too, is a broken intuition. That meaning comes from duration, from lasting. Perhaps it is the opposite. Perhaps meaning comes from finitude, from knowing there will be an end. Look again at your own life. It is not infinite. It will not last forever. And yet, does that not give weight to each moment? If you knew you would live endlessly, would today matter? Or would it blur into eternity, indistinguishable from every other day? Maybe the universe is the same. Maybe its value lies not in whether it lasts forever, but in the fact that it exists at all. So you return to the question, carrying your broken intuitions like shattered glass. Will the universe last forever? Perhaps not. Perhaps forever is a dream, a word stretched beyond its meaning. Perhaps the universe is temporary, finite, fragile, like you. And yet within that fragility lies wonder. To exist in time, to share its arc, to ask about its fate, that is enough. For now the question remains open. Time stretches ahead, mysterious, uncertain. But you know this much, intuition cannot guide you anymore. The answer lies in evidence, in theory, in the strange mathematics that describe what intuition cannot. You stand at the threshold, ready to step from broken assumptions into the evidence itself, ready to see what science has discovered about the fate of the cosmos. But for now you sit with the discomfort that time is not eternal, that forever may not exist, that the universe itself may be a story written on a finite page. The page is vast, but it is not infinite. The story continues. When intuition breaks, evidence must take its place. For centuries, people assumed the universe was static, eternal, unmoving, unchanging. It seemed obvious. The stars circled in predictable rhythms, the planets moved along their paths, the heavens looked solid and timeless. But then came the evidence, and it shattered that picture forever. The first clue came in the form of light, not just the brightness of stars, not just their sparkle, but the fingerprints written into their glow. Every element leaves its mark in light, hydrogen, helium, iron, each one an artist leaving distinct strokes on the canvas of the spectrum. By studying those fingerprints, astronomers could see not only what stars were made of, but how they were moving. Here was the revelation. Almost every galaxy we observed was moving away from us, and not just drifting slowly, but fleeing at immense speeds. Their light was stretched, shifted toward the red end of the spectrum, the cosmic equivalent of a siren lowering in pitch as it rushes away. Redshift, the signature of motion, the proof that the universe itself was not steady but expanding. This was more than a curiosity. It was a revolution, because expansion implied a beginning. If galaxies are rushing away from one another now, then in the past they must have been closer. Wind the film of the universe backward and everything converges. Galaxies, stars, matter itself, all drawn together until you arrive at a single origin. A beginning, the Big Bang. And so the first great piece of evidence emerged. The universe is not eternal in the past. It is dynamic, alive, moving. Expansion is not a theory, it is an observation, written in the very light of the galaxies themselves. But evidence rarely comes alone. In 1965, another discovery added its voice to the story. Two engineers, Arno Penzias and Robert Wilson, working on a radio antenna, kept hearing a faint hiss of static. No matter where they pointed their instrument, no matter how carefully they cleaned it, even removing pigeons nesting inside, they could not eliminate the noise. Eventually, they realized what they had found, the afterglow of the Big Bang itself. The cosmic microwave background, faint radiation spread evenly across the sky, a ghostly echo of the universe's fiery birth, the smoking gun of a beginning. With these two discoveries, redshift and cosmic background radiation, the static, eternal universe was gone. A dynamic, evolving universe replaced it. A universe with a past, a universe with a future. Pause here, think about what this means for your question. Will the universe last forever? Because once you know the universe is expanding, you must ask, how does that expansion end? Does it go on forever, carrying galaxies into eternal isolation? Or does its slow reverse collapse into a fiery end? The answer, once again, lies in evidence. Astronomers began to measure how quickly galaxies were receding, how expansion was behaving. They expected to find slowing, the tug of gravity gradually pulling everything back. It made sense. Expansion might not stop soon, but eventually the great attraction of all matter should balance the outward motion. Perhaps, given enough time, the universe would even collapse. But what they found was stranger. In the late 1990s, two teams of researchers studying distant supernovae discovered that galaxies were not just receding, they were accelerating. Expansion was speeding up, as if some unseen hand were pushing space apart more and more each moment. This was shocking. Gravity should slow expansion. Nothing we knew of should accelerate it. And yet the evidence was clear. The universe is not simply stretching. It is stretching faster and faster, like a balloon inflating with no one blowing air into it. Dark energy, that is the name we gave it, though the name explains nothing. It is not an energy we can touch or measure directly. It is a placeholder for mystery, the unknown force that drives acceleration. 70% of the universe is this unseen thing. So the second great piece of evidence enters the story. Not only is the universe expanding, but expansion is accelerating. And suddenly the future looks different. A collapsing universe, the big crunch, becomes unlikely. Instead, the universe seems destined to keep growing faster and faster, carrying galaxies beyond reach. But we cannot stop there. Evidence stacks in layers, each one adding weight. Beyond redshift, beyond microwave background, beyond dark energy, there is more. Consider the age of stars. Some of the oldest stars in our galaxy carry ages that nearly match the universe itself. Billions of years written into their compositions, their lifespans, their cooling embers. They confirm the timeline drawn by expansion. The story is consistent. A universe born 13.8 billion years ago, still expanding now, still cooling, still evolving. Or consider the distribution of galaxies themselves. They cluster in great webs, filaments of matter stretched across the cosmos, knots where gravity pulled material together, voids where little formed. The pattern is not random. It is the frozen memory of sound waves, yes, sound waves rippling through the early universe, pressure waves imprinted in the plasma before atoms even existed. Today we call them baryon acoustic oscillations, evidence written into the structure of galaxies themselves, confirming the model of an expanding, evolving universe. Pause here again, breathe, because this is what evidence does. It takes what intuition cannot hold and replaces it with something sturdier, stranger, truer. You began with a simple question, will the universe last forever? And already the evidence has carried you into unexpected territory. A universe with a beginning, a universe expanding, a universe accelerating. The story is no longer about whether the universe lasts forever like a simple flame burning in the dark. It is about the precise balance of forces, the hidden ingredients of reality, the strange rules written into space-time itself. And yet evidence is not final. It points in directions, it shapes possibilities, but it does not close them. The expansion may accelerate endlessly, leading to heat death, or it may change, revealing new physics we cannot yet see. Evidence builds, but the story remains open. Still, let yourself marvel at this. You live in a universe where you can know these things. You, a creature of dust, can look at faint starlight and hear in it the motion of galaxies, the echo of creation, the whisper of forever. That alone is astonishing. That alone reshapes what forever means. So as the evidence stacks higher, the question transforms. Not just will the universe last forever, but what kind of forever do the laws of physics allow? And as you will see, the answers are as unsettling as they are beautiful. The story continues. The evidence of expansion is undeniable. Galaxies recede, space itself stretches. The universe grows larger with every passing second. But expansion alone is not the whole story. To understand the fate of the cosmos, you must look closer into the lives of the stars, the structures of galaxies, the slow ticking of entropy written in light and shadow. Because the future of the universe is not only about space stretching, it is about how matter changes, how energy flows, how time grinds everything toward exhaustion. Begin with the stars. Every night sky you have ever seen is lit by their burning. Stars are engines, vast furnaces converting hydrogen into helium, matter into energy. That light you see across the dark, it is fuel being spent, order dissolving into radiation, entropy in action. But stars do not last forever. Their lifespans may seem eternal to you, millions, billions, even trillions of years, but they are temporary. The sun itself, steady in your sky, is halfway through its life. 5 billion years from now it will swell into a red giant, consume the inner planets, and collapse into a white dwarf, a hot cinder cooling slowly in the dark. Larger stars live even shorter lives. They burn bright, burn fast, and end in violent supernovae, scattering heavy elements across space, leaving behind neutron stars or black holes. Smaller stars, red dwarfs, burn more slowly, glowing faintly for trillions of years, far longer than the universe has yet existed. But even they will one day exhaust their fuel. So the evidence is clear. Stars are not permanent. They are chapters, not the book itself. And if stars are temporary, then the universe's light is temporary. Imagine the far future, billions upon billions of years from now. Star formation slows as gas is consumed. The great stellar nurseries, the clouds where new suns ignite, become empty. One by one the lights go out. Galaxies once glittering with billions of stars dim into shadows. Entropy writes this fate. The usable energy locked in stars is finite. As it spreads into radiation, as fuel is spent, the balance tips toward stillness. But stars are only part of the story. Look deeper into the hearts of galaxies where black holes dwell. These are the strangest objects the universe has created, not objects at all, but regions where space-time collapses in on itself. Their gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. They are sinks in the fabric of reality, swallowing matter, storing entropy. And black holes will remain long after stars have died. When galaxies grow dark, their cores will still hold these monsters, silent, massive, waiting. But even black holes are not eternal. Stephen Hawking showed us this with a revelation almost too strange to believe. Black holes radiate, not from within, nothing escapes their gravity, but from the quantum structure of space around them. Virtual particles flickering in and out of existence can become real at the edge of the event horizon, stealing energy from the black hole itself. Slowly, invisibly, black holes evaporate. The timescale is unimaginable. A black hole the mass of a star will take 1067 years to evaporate. A supermassive black hole, the kind anchoring galaxies, will take 10,100 years or more. But the law is clear, they too will vanish. And when they do, only radiation will remain, the last echoes of collapsed matter dissolving into the void. So entropy's story deepens, not just stars fading, but black holes themselves evaporating. No structure is immune. No matter how vast, how enduring, everything is consumed by time. Pause, picture this timeline in your mind. Now galaxies bright, stars burning, planets orbiting. In billions of years, the skies dim, star formation slows, galaxies thin. In trillions of years, stars are gone, leaving only remnants, white dwarfs, neutron stars, black holes. In far longer spans, even black holes evaporate, leaving radiation dispersed across expanding space. And after that, silence. Only particles, only faint energy, drifting endlessly in an expanding void. This is not speculation. It is the trajectory written by physics, by the laws of thermodynamics, by the evidence of how matter and energy behave. It is a vision called the heat death, not a sudden destruction, but a long, slow fading. Your intuition resists. It feels impossible that something so vast could end this way, not in fire, but in emptiness. Yet the evidence stacks, piece by piece, pointing toward that fate. Stars die, galaxies empty. Black holes evaporate, entropy increases. But evidence is not destiny. There are still questions, still mysteries that bend the story. Dark energy remains unknown. Its strength, its future, its very nature could alter the path. Will it continue accelerating expansion forever? Will it change, weaken, reverse? Will new physics rewrite the ending? We cannot yet know, but what we do know is this: entropy is undefeated. Everything we observe, from the smallest systems to the largest structures, confirms its law. Disorder spreads, energy disperses, balance approaches. So when you ask whether the universe will last forever, the evidence says, yes, in duration, but no, in vitality. The universe may continue without end, but not in the form you know. Not with stars, not with galaxies, not with the brilliance of light. Forever may be real, but it may be empty. Pause again, feel the weight of that possibility. A forever without warmth, a forever without creation, a forever that feels less like life and more like silence. And yet there is wonder in it too, because you are here now in the brief window when the universe is full of light. You are part of the rare era when stars shine, when galaxies burn bright, when life can ask these questions. Out of all the possible times in the universe's history, you exist in the moment when the cosmos is alive. That too is evidence. Evidence not of fate, but of perspective. Because no matter how the story ends, the fact that you are here to witness it, to imagine it, to contemplate forever, is itself extraordinary. The evidence continues to build. Expansion, acceleration, entropy, black holes, all pointing toward a universe that may not last forever in the way you once imagined. But the story is not finished. Other possibilities wait in the mathematics, in the mysteries of dark energy, in the frontiers of quantum theory. And so the question remains open, suspended between silence and surprise. Will the universe last forever? The evidence leans toward yes, but a yes that feels like no. A forever that is emptiness. A forever that redefines the word itself. The faintest evidence sometimes carries the heaviest weight. When you look at the night sky, you see stars, galaxies, the light of things still burning. But hidden beyond that brightness is a quieter glow, not from stars, not from galaxies, not from any single object. It is everywhere at once, woven into the fabric of space itself. The cosmic microwave background. It is older than any star, older than any galaxy, older than the Earth itself. It is the afterglow of creation, the cooled remnant of the Big Bang. Not fire anymore, but its echo stretched by time into microwaves, invisible to your eyes but still present, bathing every corner of space. This background radiation is not noise, it is a map. A message written across the sky containing the story of the early universe in patterns of warmth and coolness, ripples only fractions of a degree apart. Those tiny differences, so small they seem meaningless, are the seeds of everything. From them grew galaxies, stars, planets, life. The universe, as you know it, was written in those ripples. And here is where the evidence grows precise. By studying that background, scientists can measure the universe itself. Its age, its composition, its geometry. Geometry, the shape of the cosmos. It seems strange at first to ask about the shape of the universe. Space feels flat to you, infinite without curve. But on the largest scales, geometry matters. The universe can bend, it can be closed like a sphere, it can be open like a saddle, or it can be flat, perfectly balanced between the two. Each shape tells a different story of fate. A closed universe would eventually collapse, pulled back on itself in a great crunch. An open universe would expand forever, thinning into emptiness. A flat universe would ride the razor's edge between the two, expansions slowing but never stopping. For decades, no one knew which was true. Intuition could not answer it, only evidence could. So scientists turned to the microwave background, reading its subtle ripples, measuring the angles of its patterns. And the answer came back with clarity. The universe is flat, not curved like a sphere, not open like a saddle, but balanced almost perfectly. Flatness means expansion will not reverse. Gravity is not enough to pull everything back. The universe will not crunch. This alone reshapes the question. Because if collapse is impossible, then forever tilts toward expansion. The universe will not end in fire, but in something colder, emptier. But the microwave background tells more than geometry. It reveals composition. The universe is not made mostly of the matter you see: stars, planets, dust. That visible matter is only about 5%. The rest is invisible. Dark matter shaping galaxies with its unseen pull. Dark energy driving expansion with its unseen push. This composition is crucial, because the balance of these ingredients decides the universe's fate. Dark matter slows expansion, dark energy accelerates it, and the microwave background reveals their proportions with stunning precision. 70% dark energy, 25% dark matter, 5% visible matter. With those numbers, the story becomes clearer. Gravity, though strong, is outweighed by expansion. Dark energy rules, and as long as it continues, forever looks like endless stretching. Pause here, consider the strangeness of this evidence, that by studying faint microwaves, ripples frozen billions of years ago, you can know the future of everything, that the afterglow of creation can whisper whether forever is real. This is the power of evidence. It takes you beyond intuition, beyond fear, into something measurable, testable. It builds the case step by step, until forever is not a vague dream but a forecast written in data. And yet, forecasts are not certainty. Dark energy remains mysterious. We know what it does, but not what it is. We know its effect, but not its cause. Perhaps it will remain constant, accelerating expansion forever. Perhaps it will change, weakening or reversing. Perhaps it is not energy at all, but the sign of deeper physics we cannot yet see. The microwave background gives you the best snapshot yet, but it does not close the book. It leaves space for possibility, for strangeness, for futures we have not yet imagined. Still, the evidence leans toward a particular vision. Expansion forever, galaxies drifting apart until they vanish from one another's view, stars burning out, black holes evaporating, heat death. This is not intuition. This is measurement. The data does not whisper comfort, it whispers emptiness. But notice something. Even in this emptiness, even in this cold vision of forever, the evidence itself is a miracle, because the universe did not need to make itself knowable. The cosmic microwave background could have been lost, erased, hidden, yet it remains faint but clear, waiting for us to notice. And you did notice. You, the universe made conscious, built instruments to detect its faint hiss, built theories to interpret its patterns, built meaning from its silence. You looked at the sky and found not just stars, but the birth cry of existence itself. That is wonder. So here the evidence stack grows higher. Expansion confirmed, acceleration measured, geometry revealed, composition understood, all pointing toward a universe that does not last forever in light, but perhaps lasts forever in silence. The question remains, will the universe last forever? The evidence says yes, but not in the way your heart once hoped. Not with eternal stars, not with eternal warmth, but with eternal expansion, eternal entropy, eternal emptiness. Still, the evidence is not done. There are more layers to consider. The life cycle of stars, the destiny of galaxies, the evaporation of black holes. Each adds weight, each sharpens the vision of forever. And so you carry the question forward with evidence now in your hands. The universe has a beginning. The universe expands. The universe accelerates. The universe is flat. Forever, then, is not promise but prognosis. You now stand at the edge of evidence looking forward. Expansion is real. Acceleration is real. Entropy is relentless. The universe is flat. The ingredients of reality, dark matter, dark energy, visible matter, are known in their proportions. All of these pieces point toward not only a beginning but also a trajectory. And so, with the evidence stacked high, you can now ask with more precision, how does the universe end? 3 main futures emerge from the data. Each one is unsettling. Each one is strange. Each one redefines what forever might mean. I begin with the quietest ending, the big freeze. This is the most widely accepted future, given what we know of dark energy. In this scenario, acceleration continues. Galaxies drift farther apart, faster and faster. until eventually they vanish from one another's horizons. The universe does not end with a bang, but with isolation. Imagine it. Billions of years from now, new stars still form, though more slowly. Galaxies still shine, though dimmer. But as time passes, fuel runs out. The great stellar nurseries empty. The lights begin to fade. In 1 trillion years, most galaxies are dark, their stars burned out. White dwarfs, neutron stars, black holes remain, but no new suns are born. In unimaginable spans, 10-20 years, 10-30 years, even those remnants fade. White dwarfs cool into black dwarfs, invisible lumps of matter. Neutron stars decay, black holes dominate. And then even black holes vanish. Over 10,100 years or more, they evaporate into radiation, their last whispers dissolving into the void. What remains? A universe of thin particles, scattered photons, cold radiation stretched across infinite space. No heat differences, no usable energy, no structures, just equilibrium, entropy fulfilled. This is heat death, a forever of silence, not destruction but exhaustion. Pause, feel the unease of that vision. A forever that is not life, not warmth, but emptiness spread endlessly. But this is not the only possibility. Consider instead the Big Rip. Here, dark energy does not remain constant. Instead, it grows stronger. Expansion accelerates not gently but violently. In this future, galaxies do not merely drift apart, they are torn apart. Gravity itself cannot hold them. Stars scatter, solar systems unravel, planets are ripped from their orbits, and the acceleration does not stop there. Eventually, even atoms themselves are torn. Protons and neutrons ripped apart by the expansion of spacetime itself. Reality dissolved into its smallest pieces. The timeline depends on how dark energy evolves. It could be billions of years away or sooner than you think. But in this vision, the universe does not end in silence. It ends in dismemberment, a final tearing of everything. This is forever as violence, a forever that grows so powerful it destroys itself. And yet there is one more vision, less likely but not impossible, the Big Crunch. Here the assumption is that dark energy is not eternal, that its strength changes, weakens, disappears. If that happens, gravity regains its pull, expansion slows, galaxies stop receding, the universe halts. Then in reverse, the universe contracts, galaxies draw closer, stars collide, black holes merge, the entire cosmos folds back in on itself. Heat rises, density grows, until everything, every particle, every photon, every fragment of space collapses into a single point, a mirror of the Big Bang, a final implosion. And from that collapse, some suggest a new beginning, a new expansion, a new universe, a cycle of bangs and crunches repeating forever. But evidence does not lean that way. The universe is flat, not closed. Dark energy shows no sign of fading. The Big Crunch is not the favored ending, but science leaves space for the unexpected. So the evidence gives you 3 endings. The Big Freeze, silence. The Big Rip, violence. The Big Crunch, collapse and perhaps renewal. None of these are comforting. None feel like the forever you once imagined. And yet they are not equal in likelihood. The weight of evidence favors heat death, the Big Freeze. Expansion continues, dark energy dominates. The universe grows colder, darker, emptier. A pause here again. You asked if the universe will last forever. The evidence says yes, in a way. Time may not stop, expansion may not halt, but the forever you are left with is not eternal light, not eternal warmth. It is eternal silence, a forever where nothing happens because nothing can. This is the strange answer science offers. Forever is real, but it does not mean what you hoped. It is not eternal story, but eternal stillness. And yet remember this, evidence is not final. Dark energy remains mysterious. Entropy, though undefeated, may not be the whole picture. Quantum physics, untested at the largest scales, may alter everything. The evidence stack is strong, but not complete. So you are left with a paradox. Forever may be emptiness, or forever may hold surprises still hidden. The only certainty is uncertainty. But here is the wonder. You are alive now in the brief window when stars still shine, when galaxies still glitter, when the universe is not yet silent. You are alive to ask these questions, to build telescopes, to measure microwaves, to imagine endings. And that is extraordinary, because whether the universe ends in silence, violence, or collapse, you are here in its moment of light. So you hold the evidence in your hands: redshift, microwave background, geometry, dark energy, entropy, black holes, possible endings. Each piece brings you closer to an answer. Each piece reshapes your vision of forever. The universe may last forever, but forever may mean something stranger than you imagine. The evidence is heavy. It points in one direction: expansion, acceleration, entropy. The big freeze as the likeliest fate. A universe that lasts forever, but only in silence. And yet evidence is not certainty. Evidence is light scattered across distance, filtered through instruments, interpreted through theory. Evidence is always partial, never complete. The universe is larger than your measurements, stranger than your equations, older than your models. So now you must challenge what you think you know. The counter case begins with dark energy. 70% of the universe unseen, unexplained. You named it because you had to, but the name gives no understanding. Dark energy is not something you have measured directly. It is inferred, a placeholder for the acceleration you see. You observe galaxies fleeing faster than expected, and you insert dark energy into your equations to make the math balance. But what if you are wrong? What if acceleration is not driven by a mysterious energy, but by something else? Perhaps your theory of gravity is incomplete. Perhaps the equations of Einstein, though powerful, are not the final. Perhaps the cosmos bends in ways your models do not yet capture. This is not just speculation. Physicists actively debate it. Find gravity, hidden dimensions, new fields of physics. Each could alter the interpretation. Each could shift the story of forever. If dark energy is not what you think, then the future is not what you think. Expansion may not continue forever. Acceleration may not hold. Forever may change shape. Even if dark energy is real, it may not be constant. You assume its strength remains steady across time. But what if it evolves? What if it weakens, fades, even reverses? Then the universe could stop expanding, could collapse, could cycle in ways your evidence does not predict. So the first crack in the evidence is uncertainty. Dark energy, the very foundation of your forecast, is a mystery wearing a borrowed name. Now consider entropy. The second law of thermodynamics is firm, tested, unbroken. But entropy is a law inside time. And if time itself is part of the universe, if time itself can end, then entropy's rule may not stretch as far as you assume. Perhaps the arrow of time bends differently in the deep future. Perhaps new physics rewrites the law. Perhaps what you call heat death is only a phase, a chapter in a longer story you cannot yet see. Your evidence leans towards silence, but your ignorance leaves room for renewal. Then there are black holes. Hawking radiation predicts they will evaporate, but this is not observed. It is a theory, powerful and persuasive, but not yet tested. If black holes endure forever, if they do not truly evaporate, then the universe's fate looks different. Instead of silence, you may have eternal prisons, structures that last without end, islands of mass and gravity scattered across infinite expansion. Is that forever? Perhaps a darker forever, but still a crack in the smooth story of heat death. And then, deeper still, the counter case of quantum uncertainty. At the smallest scales, physics is probabilistic, not deterministic. Virtual particles flicker from nothing, fields surge with energy, chance rules as much as certainty. Over infinite spans of time, what strange possibilities emerge? Could fluctuations spark new universes? Could order arise again from chaos? Could forever contain not silence, but cycles of renewal, new beginnings hidden inside emptiness? This is not idle imagination. Theories like eternal inflation and quantum cosmology suggest exactly this, that our universe may be one bubble in a larger froth, one cycle in a chain without end. If so, then the end you imagine, heat death, big rip, big crunch, may not be final. It may be transition. Pause here. Notice how fragile your evidence becomes when you lean too heavily on it. Yes, expansion is observed. Yes, acceleration is measured, but these are not the whole story. They are fragments. You see only what your instruments allow, only what light reveals. You interpret through the lens of human theory, which is powerful but provisional, always provisional. And the cosmos is vast enough to hide surprises. Think of history. Once you believed Earth was the center. Once you believed the stars were eternal. Once you believed time was absolute. Each belief was supported by evidence, by observation. Each was shattered by deeper discovery. Why should your present knowledge be immune? So the counter case whispers, be careful. Do not cling too tightly to the neat endings. The universe may last forever or it may not, but the paths you see now are not the only ones. Imagine for a moment a universe where dark energy reverses. Expansion slows, halts, contracts, the big crunch returns. Galaxies fall together, stars collide, black holes merge, heat rises, density grows, and then who knows, perhaps another bang, perhaps another cycle, forever not as silence but as rhythm. Or imagine a universe where quantum fluctuations spark new beginnings even in emptiness, where pockets of order form spontaneously, where new universes bud from the husk of the old, forever not as death but as branch. Or imagine a universe where time itself is not linear, where entropy reverses, where beginnings and endings fold into one another, forever not as arrow but as loop. These visions are speculative, yes, but they remind you evidence is never complete. The cosmos is too strange, too vast, too mysterious to be reduced to one end. So you must hold two truths at once. The evidence you have is powerful. It points toward expansion, toward heat death, toward a forever of silence that cannot be dismissed. But the evidence you lack is even greater. Dark energy unknown, quantum gravity untested, the deep structure of time itself uncertain, that cannot be dismissed either. Forever then is not settled. It is not silence alone, it is possibility. Pause once more, let the doubt sink in, but also the wonder. Because this doubt is not failure, it is the heart of science. To question even your strongest evidence, to admit ignorance, to remain open to what you do not yet know. That humility is what keeps discovery alive. So the counter case does not erase the evidence. It complicates it, it deepens it. It reminds you that the universe is larger than certainty, stranger than prediction, richer than endings. Will the universe last forever? Perhaps, but perhaps not. And even if it does, forever may not mean what you think. Doubt is not emptiness. Doubt is possibility. Once you step outside the neat forecast of heat death, once you admit that dark energy is mysterious and entropy may not be the whole story, new visions of forever begin to emerge. Alternative cosmologies, other ways the universe might unfold, other ways forever might appear. Begin with the idea of cycles. For thousands of years, human cultures imagined time as circular, not linear. The seasons turn, birth leads to death, death to renewal. Rivers flow into seas, seas into clouds, clouds into rain, rain into rivers again. To ancient eyes, eternity was rhythm, not line. Science has in some ways returned to that vision, because one alternative to heat death is a universe that does not end but repeats, expands, contracts, collapses, begins again. A cosmic heartbeat. This is the theory of the cyclic universe. Picture it, expansion continues for billions of years, but dark energy does not remain constant. It changes, weakens, reverses. Gravity regains its hold. Galaxies slow, stop, drift back together. The universe contracts, heat rises, matter collides, everything folds inward. At last, everything collapses into a singularity, the big crunch. But perhaps that is not the end. Perhaps at the moment of collapse, conditions mirror the beginning. Temperatures rise, densities soar, and a new expansion bursts forth, a new big bang. Not the rebirth of the same universe, but the birth of a new one. A fresh cosmos growing from the ashes of the old. If this is true, forever is not silence. Forever is rhythm. The universe is dying and being born in endless sequence. Some theories even suggest that traces of previous cycles might remain, that certain patterns in the cosmic microwave background, certain statistical ripples, could be the scars of past universes before ours. Evidence not yet conclusive but tantalizing. A whisper that forever may be larger than a single line of time. But cycles are not the only alternative. Consider bouncing models. In these, the Big Bang was not the beginning at all, not creation from nothing, but a bounce from a previous state. The universe once contracted, then rebounded into the expansion we see today. Perhaps it will bounce again endlessly. Here, forever looks different. Not a straight line into emptiness, but a sequence of arcs, each universe birthing the next. Now push further, consider the multiverse. This is not one universe repeating, but many universes existing side by side, or one after another, or budding endlessly like bubbles in a vast cosmic foam. Our universe began with the Big Bang, yes, but what if that bang was only one spark in a larger fire? What if inflation, that brief, rapid expansion at the universe's birth, happens again and again in other regions of reality, creating new universes without end? If so, then forever is not just about the fate of our universe. Forever is about an endless landscape of universes, each with its own laws, its own fates, its own possibilities. Some universes may collapse, some may freeze, some may rip apart, some may never form stars at all, and some, like ours, may bloom with galaxies, with planets, with life that wonders. Pause, feel the strangeness of this vision. Because here the question changes. Not will the universe last forever, but which universe? If the multiverse is real, then our universe may end, but forever goes on elsewhere. Eternity is not silence but diversity, not emptiness but endless variation. And perhaps in some corner of that multiverse, other beings are asking the same question. But multiverse theories are speculative. They rest on mathematics, on hints from inflation, on interpretations of quantum physics. They are not confirmed, they may never be directly observable, yet they remain part of the counter case, the reminder that forever might be stranger than heat death. Even within our own universe, quantum physics suggests renewal. In the emptiest vacuum, fluctuations occur. Particles flicker into existence, then vanish. Over infinite spans of time, could those fluctuations spark new beginnings? Could empty space itself give birth to fresh universes? Some cosmologists believe so. That heat death, far from being the final word, is only the background for renewal. That eternity is not silence but rebirth from emptiness itself. Here, forever is not static, it is generative. It is a garden seeding new universes even from void. But step back for a moment. Notice how each of these counter cases feels different from the evidence stack. Heat death is cold, final, bleak. The counter cases are dynamic, rhythmic, branching. They feel more alive. This is not an accident. Humans crave cycles, renewal, continuation. A forever that leads to silence feels unbearable, so we imagine alternatives. Science provides the frameworks, the equations, the possibilities. But beneath them is also longing, the desire that forever means more than emptiness. Does that make the counter case less true? Not necessarily. It only makes you cautious, because desire and truth do not always align. And yet you must admit, the evidence is not closed. The cracks are real, dark energy unknown, entropy untested at infinity, quantum physics open to surprises. So the counter case matters. It keeps humility alive, it keeps forever open. Pause again, picture the possibilities side by side. Heat death, a forever of silence. Big rip, a forever of tearing. Big crunch, a forever of collapse and rebirth. Cycles, a forever of rhythm. Multiverse, a forever of variation. Quantum renewal, a forever of rebirth from emptiness. Each one unsettling, each one incomplete. The truth is this: You cannot yet know which forever is real. The evidence leans one way, but the mysteries leave space for others. So you return to the question, now with both evidence and doubt in hand. Will the universe last forever? Perhaps yes, perhaps no, perhaps both, depending on how you define forever. Perhaps forever is silence, perhaps forever is rhythm, perhaps forever is larger than you can imagine. And in that uncertainty, wonder blooms. Because to not know is not failure, it is possibility, it is openness. It is the space in which discovery lies. You trust the laws of physics the way you trust the ground beneath your feet. Gravity pulls, light travels at its speed, electrons carry their charge. The universe feels stable because its rules seem stable. But what if they are not? What if the very constants you rely on, the speed of light, the strength of gravity, the charges of particles, are not eternal truths but temporary arrangements? What if forever is reshaped not by entropy alone, not by dark energy alone, but by changes in the very laws themselves? This is the unsettling counter case, that the foundations of physics may not be forever. Begin with the speed of light, 300,000 kilometers per second, the ultimate speed limit. Nothing with mass can exceed it. Every calculation in physics depends on it. It defines space, time, causality. But is it truly constant? Some theories suggest it may have been different in the early universe. That during inflation, when space expanded faster than light could cross it, the rules of speed were not what they are now. Even small variations would change everything: how galaxies formed, how the cosmos grew, how forever unfolds. If light speed is not eternal, then neither is time as you know it, because relativity ties space and time to light's pace. Change the speed and you change the rhythm of reality. Now consider gravity. It feels permanent. You drop a stone and it falls. Planets orbit stars. Stars orbit galactic centers. Gravity shapes the architecture of the universe. But what if gravity is not fixed? Some alternative theories propose that gravity weakens or strengthens over time, that its strength is tied to hidden dimensions, to evolving fields. If so, then the universe's fate changes. A stronger gravity might halt expansion, pull everything back into collapse. A weaker gravity might let acceleration race unchecked, tearing the cosmos apart. In either case, the forever you predict today is not the forever that will arrive tomorrow. Pause here, feel the ground shift again, because you see how fragile your certainty is. All your forecasts, big freeze, big rip, heat death, assume the laws of physics remain what they are now. But if they change, all bets are off. Even the constants of particle physics may not be stable. The charge of the electron, the mass of the proton, the strength of the strong and weak nuclear forces. You assume they are fixed, but why? They may be parameters set by deeper laws we do not yet see. They may drift over vast timescales nudged by cosmic evolution. If they shift even slightly, atoms may dissolve, chemistry may fail, stars may not form, the universe itself may transform into something unrecognizable. And then there are vacuum states. Quantum physics tells us the vacuum of space is not empty. It has energy, structure, fields. But is our vacuum the lowest possible state, or only a temporary one? If it is temporary, then one day it could decay. A vacuum collapse, a bubble of lower energy vacuum forming somewhere, expanding at the speed of light, rewriting the laws of physics as it passes. No warning, no escape. Inside that bubble, everything changes. Particles as we know them cease to exist. Forces take new values, chemistry fails, stars vanish. Forever in that vision is not silence but rupture. Not heat death, not rip, not crunch, but transformation. The universe as we know it replaced instantly by something else. This possibility is not fantasy. It is rooted in real physics. Our current vacuum may be metastable, stable enough for now, but not absolute. Calculations of the Higgs field suggest it could, in principle, decay, perhaps in 1 billion years, perhaps tomorrow. It is terrifying, yes, but it also reshapes forever, because if vacuum decay is real, then eternity is not emptiness. Eternity is sudden change. A pause again. Notice the pattern. Every constant, every law you thought was eternal is now revealed as possibly fragile. The speed of light, the strength of gravity, the forces of particles, even the vacuum itself, none are guaranteed, none are safe. And so the counter-case deepens. Perhaps there is no forever at all. Perhaps forever is only the illusion of stability stretched thin across human time. Perhaps the laws themselves have lifespans and the universe is not only temporary in form but temporary in rule. This is not comforting, it is not easy to hold, but it is necessary because science is not about clinging to certainty. It is about questioning even your foundations. Think of history again. Once you believed space and time were separate. Once you believed energy was conserved absolutely. Once you believed atoms were indivisible. Each law seemed eternal until evidence broke it. Why should today's laws be different? So the question of forever is no longer just about stars and galaxies, entropy and expansion. It is about the fabric itself. Will the rules last forever, or will they too unravel? If the rules change, then all your endings change. Heat death may not arrive. The big rip may not happen. Instead, a new physics may take the stage, reshaping the cosmos into something you cannot yet imagine. And here, forever becomes something stranger. Not a simple silence, not a cycle, not even a multiverse, but a shifting stage where the laws themselves are impermanent. A forever that transforms unpredictably, endlessly. Pause one last time in this thought. Because this is the counter-case in its purest form, not certainty but humility, not endings but openness, not forever as a single answer but forever as a question that cannot be closed. Will the universe last forever? If the laws themselves can die, then the word forever loses meaning. There is only what is for as long as it lasts. And maybe that is the truest lesson. That nothing, not even the rules, are safe from impermanence. You've looked outward towards stars, galaxies, dark energy, entropy, black holes, and the laws of physics themselves. But there is another frontier to question, one even closer, the way you think. Because forever is not only a physical concept, it is also a human one, and perhaps your mind is not built to hold it. Start with time. You experience time as a river, flowing, steady, carrying you from one moment to the next. You imagine past stretching behind, future stretching ahead, with the present as a moving point along the line. But this is only perception. Physics suggests that time may not flow at all. That past, present, and future may all coexist, laid out like pages in a book. You turn through them one by one, but the book itself is already written. This is the block universe view. Time as a dimension, not a river. Every moment equally real, equally permanent. From this perspective, forever is not an endless line. Forever is the totality of all pages already there, complete. But if this is true, then your question, will the universe last forever, is shaped by illusion, because lasting implies flow, it implies change. If time does not flow, then the universe is not lasting at all. It simply is. Beginning and end are only features of the book, not the experience of the book itself. A pause, let that sink in. You have been asking about forever as if time itself were the stage. But maybe time is part of the play. And if so, your question is misplaced. Even your sense of beginnings and endings may be illusions. Think of a sunrise. You see the sun rise, move across the sky, set. It feels like the sun is moving, but in truth the earth rotates. The sun does not rise or set. Your perception creates the illusion. Now think of the Big Bang. You see it as a beginning, a first moment. But what if that is just another illusion of perspective? What if the Big Bang is not the true beginning, but only one feature of a larger structure you cannot yet see? Our words betray us. Forever, always, never. These are human tools built for human lives, useful for counting years, for measuring memory, for giving shape to stories. But when stretched across the universe, they may break, they may not fit. It is like trying to measure the ocean with a teacup. The tool is too small, and yet you cannot escape it. You are a creature of time, bound to it, perceiving it through memory and anticipation. Your questions are shaped by your mind, and your mind is shaped by survival, by evolution, by the scale of days and years. Not billions of years, not eternity. So perhaps your discomfort with forever is not about the universe at all. Perhaps it is about the mismatch between your mind and reality. Your mind craves closure. Every story you know has an ending. Every life you witness has a span. So when you face a universe that may not end or may end in ways beyond comprehension, you feel unease. Not because the universe is wrong, but because your intuition cannot stretch that far. This is why heat death feels unbearable, why Big Rip feels terrifying, why cycles feel strange. It is not only the science, it is your wiring. Even the word end may be misleading, because what would it mean for the universe to end? End for whom? End compared to what? If time itself ceases, then there is no one left to mark the ending, no framework in which end has meaning. Here, the counter case is not a theory of physics, but a theory of perspective. That the question itself may be unanswerable, not because the universe hides the truth, but because your mind cannot frame it correctly. Pause here, let yourself feel both the humility and the liberation of that thought. You are small, your mind is small, the universe is vast. That mismatch is not a flaw, it is the condition of being alive. And yet here is the paradox. Even if you cannot fully hold forever, you can still approach it. You can still gesture toward it with equations, with metaphors, with questions whispered in the dark. You may not grasp it, but you can feel its edges. That too is extraordinary. Think of how far you've come, from wondering if stars are eternal to seeing them as finite, from assuming time is steady to learning it bends, from believing the laws of physics are fixed to questioning their permanence, from clinging to forever as comfort to breaking it open as mystery. All along, the universe has been both knowable and unknowable. Evidence brings you closer, perspective pushes you back, the balance keeps you humble. So what is the counter case? It is this: perhaps the question, will the universe last forever, has no single answer. Not because the universe lacks one, but because your language, your perception, your mind cannot capture it. Forever may not exist as you mean it. Or forever may exist in a way that is alien, unreachable. And maybe that is all right. Because in the end, the value is not in the answer. The value is in the asking. The act of wondering pulls you closer to the cosmos, stretches your mind, cracks your intuition, makes you more than just a creature of survival. It makes you part of the story. So as the counter case closes, you are left in a strange position. Evidence stacks toward endings, heat, death, rip, freeze. Counter cases reopen the field, cycles, bounces, multiverse, vacuum, decay, shifting laws, illusions of time. Both speak truth, both hold weight. And you, fragile and finite, stand between them, asking, imagining, feeling both dread and awe. Perhaps that is what it means to be human, to carry questions too vast to answer, to live inside mysteries too large to resolve, and to love the asking anyway. Will the universe last forever? The evidence says one thing, the counter case says another. The truth, perhaps, is that the question is larger than both. And so, once again, the story does not end. It continues. You've heard the evidence: expansion, acceleration, entropy, black holes evaporating into silence, the geometry of the cosmos pointing toward endless thinning, a forecast of forever as emptiness. You've heard the counter case: dark energy unknown, laws not guaranteed, cycles, bounces, multiverses, the possibility that forever is rhythm or transformation or illusion. Now you must hold them together, not one against the other, but both at once. Because the universe does not ask you to choose, it asks you to notice, to accept that certainty and uncertainty can coexist, each sharpening the other. Begin with the evidence again. It tells you that the universe had a beginning. That much is almost beyond dispute. The light of galaxies, the microwave background, the age of stars all converge. The Big Bang happened. You live in its afterglow. But already the counter case joins in. The Big Bang was not necessarily the beginning of everything. It may have been a transition, a bounce, a birth from something else. Evidence cannot see beyond that horizon, so you must accept both, a beginning you can measure and a mystery beyond it. Now look at expansion. The galaxies are fleeing, yes, the data is clear. Redshift does not lie, the universe is stretching. But the cause, dark energy, is unknown. Evidence shows the effect, but not the engine. You must accept both, expansion as fact, dark energy as mystery. Then entropy, the law is firm. Energy spreads, order dissolves. Stars will die, galaxies will dim, black holes will fade. But again, the countercase complicates it. Entropy is a law inside time. If time itself is finite or cyclical or illusory, then entropy may not stretch into forever. You must accept both, the inevitability of entropy here and now and the possibility that its rule is not eternal. This is the rhythm of synthesis. Evidence speaking, countercase answering, the two weaving into a deeper understanding. A pause here, feel what this means. Because you began with a simple question, will the universe last forever? You wanted a yes or no, a promise or a verdict, but the journey has reshaped the question itself. Forever is not simple. Forever is not one thing. Forever is not even guaranteed to exist. Instead, forever is a spectrum of possibilities, each one drawn by evidence, each one broken open by doubt. This is not failure, this is truth. Think of light, it behaves like a particle, it behaves like a wave. Both descriptions are true, and yet neither is complete. The paradox is not a flaw, but a feature of reality. So it is with forever. The evidence and the counter case are not enemies. They are partners, each revealing the edges of the other. Take heat death. Evidence says it is the likeliest outcome. But what is the meaning of likeliest when the unknowns, dark energy, quantum fields, shifting laws may reshape everything? You cannot hold certainty, but you can hold possibility. Take cycles, counter cases suggest them. Evidence does not forbid them. Together they form not a prediction but an opening. Take the multiverse. Evidence hints through inflation and quantum theory. Counter cases amplify, imagining branching eternities. Neither proves it, both keep it alive. Do you see the pattern? The point is not to close the question. The point is to keep it open, to expand its horizons. This is synthesis, not choosing between evidence and doubt, but learning to stand in the space where they meet. And here is the deeper truth. Perhaps forever was never meant to be answered. Perhaps it was meant to be lived. Because what does the evidence and countercase together tell you? That the universe is temporary in some ways, eternal in others. That stars will die, but atoms may last. That time may end, but energy may transform. That endings may be silence or renewal or both. And in the middle of that you exist. You, finite and fragile, alive in the thin slice where stars burn, galaxies shine, and consciousness can ask questions. This, too, is forever. Not forever as duration, but forever as significance. The fact that you are part of the universe's story, written in its matter, carried by its time, asking about its fate, that is eternal in its own way. A pause again, feel this in your chest. You wanted to know whether the universe will last forever. The synthesis shows you that forever is not a single answer. Forever is a mirror. When you ask if the universe will last, you are also asking if meaning lasts, if love lasts, if anything of you endures. The evidence gives one answer. The counter case gives another. The truth may be both. Because meaning is not only in duration. Meaning is in existence, in the moment itself, in the fact that the universe is here at all and that you are here to wonder about it. The stars will die, the galaxies will fade, time itself may bend or end, but the wonder you feel now, that is real. That is part of forever, not in time, but in being. So synthesis does not solve the question, it transforms it. Will the universe last forever? Perhaps in silence, perhaps in cycles, perhaps not at all, but forever is not the promise you thought it was. It is the invitation to wonder, to live, to marvel in the face of impermanence. This is not defeat, it is liberation. Because if forever is uncertain, then every moment shines brighter. If endings are inevitable, then beginnings are precious. If the laws may shift, if time may fail, if the cosmos may collapse, then the fact that you exist now in this rare window of starlight is more extraordinary than any forever could promise. So you hold both truths together, evidence and counter case, certainty and doubt, silence and rhythm, end and renewal. And you live inside the tension. Perhaps that is the real answer. Forever is not something the universe gives you. Forever is something you create by noticing, by asking, by loving, by existing fully in the fleeting now. You've held the evidence in one hand, the counter case in the other. Now the synthesis begins to expand beyond science itself into something more intimate. Because when you ask if the universe will last forever, you are not only asking about galaxies and time, you are asking about yourself. Your life is a smaller echo of the cosmos. You too had a beginning. You too are made of fuel that will one day run out. You too live in the balance between order and entropy. The universe will not burn forever, neither will you. Pause here, let the parallel settle in. Because the fear you feel at the thought of the universe ending is the same fear you feel about your own ending. Mortality written large, impermanence scaled to infinity. To wonder whether the cosmos will last forever is to wonder whether anything lasts, memory, love, meaning. And the synthesis whispers, the two are not separate. The carbon in your cells was forged in the death of stars. The calcium in your bones was born in ancient supernovae. The iron in your blood once burned in a furnace billions of years ago. You are not separate from the universe. You are its continuation, its expression, its witness. When you breathe the universe. When you die, you return to it. Your impermanence and its impermanence are bound together. So when you hold evidence and counter case together, you are also holding yourself. If the universe ends in silence, heat, death, then you too are part of that silence, a brief note in its song carried forward into stillness. If the universe renews, cycles, bounces, multiverse, then you too are part of that renewal. Your atoms scattered into future forms, your existence folded into larger rhythms. And if time itself is not what it seems, if beginnings and endings are illusions, then you too are already eternal in ways you cannot yet imagine. A pause again, breathe with it. Because what the synthesis shows you is that forever is not just a question of physics. It is a question of perspective. You fear endings because you think meaning requires duration. That love must last forever to be real. That life must be eternal to matter. That the universe must endure endlessly to make your existence worthwhile. But look closer, is that true? When you listen to a song, does it lose its beauty because it ends? When you watch a sunset, does its impermanence make it meaningless? When you hold someone you love, is the embrace less real because you cannot hold it forever? No, the meaning is in the moment. The beauty is in the brevity. The value is in the impermanence. Perhaps the universe is the same. Perhaps the question, will the universe last forever, misses the point. Because even if it doesn't, even if everything dissolves into silence, the fact that it was here at all is already miraculous. And if it does last forever, in some form you cannot yet see, then forever is not a guarantee of meaning either. Eternity can be as empty as silence. A story with no ending can feel less alive than one with a sharp, clear close. So the synthesis asks you to step beyond forever, to see meaning not in whether the universe endures, but in the fact that it exists. To see your own life not in terms of how long it lasts, but in the fact that it is happening now, that it is part of the cosmos, that it is woven into forever's fabric whether or not forever continues. This is the bridge between science and soul. The evidence gives you probabilities, the counter case gives you possibilities, but synthesis gives you perspective, a way to live inside the question without fear. Because the universe will do what it does, expansion, contraction, silence, renewal, it will follow its laws, known or unknown. You cannot control it, you cannot stop it, you cannot even fully understand it. But you can live inside it. You can marvel at its beauty even in impermanence. You can love even in brevity. You can find meaning not in forever, but in now. And perhaps that is the deeper answer. Will the universe last forever? You do not know, you cannot know, but the question itself is what matters. The asking is what connects you to the stars. The wondering is what makes you part of the cosmos. Think of how extraordinary it is. You, a creature of dust, built of atoms that once burned in stars, can look upward and ask about forever. You can measure the faint glow of the microwave background, detect the redshift of galaxies, calculate entropy, imagine heat death. You can speculate about cycles, bounces, multiverses, and vacuum decay. You can hold evidence and mystery at the same time. No other being that you know of has done this. Perhaps others exist elsewhere in the cosmos, perhaps not. But here on this small planet, in this brief window, you have become the voice of the universe asking about its own fate. That too is forever, not in time but in meaning. I pause once more, because the synthesis is not about resolving the question. It is about changing your relationship to it. You no longer need forever to be certain or comforting or endless. You can let forever be vast, uncertain, unknowable, and still find beauty in it. The evidence points one way, the counter case opens others, but you do not need to choose. You can let them coexist, let them hold tension, let them mirror the complexity of life itself. And so when you look at the night sky again, you may feel something different, not dread at the thought of endings, not false comfort at the dream of eternity, but wonder at the sheer fact of it all. The stars, the galaxies, the darkness between them, the fragile window in which you exist, whether forever holds silence or renewal, collapse or cycle, it has given you this moment, and this moment is enough. When science gives you probabilities and philosophy gives you possibilities, where do you turn next? Toward metaphor, toward art, toward music, because the universe is not only equations and evidence, it is also story, it is also rhythm, it is also song. And perhaps the way you hold forever is not only through calculation, but through the patterns you already live with, the stories you tell, the music you hear, the art you create. Think of music first. Every song has a beginning and an end. That is what gives it shape. A note alone is not music. Silence alone is not music. Music lives in the flow, in the rise and fall, in the fact that the sound will stop. You do not demand that a song last forever to find it beautiful. In fact, it is its finiteness that makes it precious. A melody repeated endlessly loses its power, but when it arrives, lifts and fades, you treasure it. The universe may be the same. Perhaps it is not meant to last forever. Perhaps its value lies in the fact that it rises, burns, fades, ends, like a cosmic symphony stretching across billions of years, with crescendos of star formation, quiet passages of dark energy, dissonant chords of collapse, heat death, big rip, big crunch. These may not be failures of forever. They may be cadences, the final notes of the song. Pause here, imagine the universe as a piece of music. You are hearing it mid-melody. The stars are the violins, galaxies the drums, black holes the bass. Entropy is the slow diminuendo, the quieting of sound. And you are part of the music, a brief phrase played once and never again. Now think of art. A painting is not infinite. It does not move, it does not grow. It exists within boundaries, framed, finished. Yet within those boundaries it holds worlds. The universe may be the same. It may be finite in time, finite in space, finite in story. But within that finitude it contains galaxies, stars, life, thought. Its beauty does not depend on endlessness. Its beauty depends on form. Even if the canvas fades, even if the paint cracks, the act of its existence is already enough. And think of stories. Every story has an ending. That is what gives it weight. You read a novel not expecting it to go on forever, but hoping its ending will illuminate its journey. You listen to myths and epics not because they promise eternity, but because they promise meaning within limits. The universe may be the same. Perhaps it is not a tragedy if it ends. Perhaps it is simply a story complete. In this light, forever itself begins to look less like salvation and more like distortion. A story that never ends is not a story. A song that never ends is not music. A painting that tries to stretch without boundary is not art. So why demand that the universe last forever? Pause again, let yourself feel the shift. Because when you step into metaphor, you begin to see endings differently. You begin to see them not as failures, but as forms. You begin to see that impermanence is not emptiness, but structure. Music without ending is noise. Stories without ending are chaos. Art without boundary is blur. And so, universes without endings may not be universes at all. Perhaps this is why heat-death feels like silence, why the big rip feels like violence, why cycles feel like rhythm. You are translating physics into the metaphors of human life. You cannot help it. It is how you understand. And maybe that is not weakness, but strength. Because metaphors are bridges. They let you carry the incomprehensible across the river of your mind into forms you can touch. You cannot truly imagine eternity, but you can imagine a song. You cannot truly picture entropy across 10,100 years, but you can imagine silence at the end of music. You cannot truly conceive of multiverses, but you can imagine stories side by side, branching, endless. This is how you live with forever, not by solving it, but by shaping it into metaphor. Now zoom out. What metaphor feels truest to you? If you imagine the universe as music, then forever is cadence. The big freeze is a slow fade to silence. The big rip is a dissonant crash. The big crunch is a return to the opening chord, a cycle of themes repeating. If you imagine the universe as art, then forever is frame. The canvas may crack, the paint may peel, but within it lies a vision that was real, luminous, complete. If you imagine the universe as story, then forever is conclusion. Heat-death is an epilogue of quiet. A crunch is a tragic finale. A multiverse is a library without end, each universe another book on the shelf. Which resonates, which metaphor eases your chest, softens your fear? That answer is not physics, it is you. Because synthesis is not only about science, it is about how you, a finite being, live with infinite questions, how you translate forever into something you can carry, something that makes sense of your brief life inside the cosmos. Pause once more. Think of your own life as music, a song that begins, rises, falls, ends. You do not demand immortality to find it meaningful. You find meaning in the fact that it happens at all. Think of your life as art, a canvas bounded by birth and death, yet filled with color and line, filled with choices and love and memory. Think of your life as story, a narrative with a beginning and end, but no less real for its limits. The universe may be all three: music, art, story, impermanent, finite, meaningful because of its boundaries. And so, synthesis brings you to a strange peace. Whether the universe ends in silence, collapse, or renewal, it is still beautiful. It is still music. It is still art. It is still story. Forever is not required. Because the beauty is not in endlessness. The beauty is in the shape. And so when you ask, will the universe last forever? The answer is less important than the asking. The asking itself is part of the music, part of the art, part of the story. You have followed the evidence into silence. You have followed the counter case into possibility. You have woven both into metaphor, into music, art, story. And now the synthesis calls for one final step, to zoom out as far as you can, until the question itself begins to change shape. Because when you ask, will the universe last forever, you are not only asking about stars and galaxies, you are asking about being, about meaning, about the strange miracle of existence at all. Step back, see the full arc. The universe has a beginning, the Big Bang, 13.8 billion years ago. From that moment of density and fire, space and time expanded. Galaxies formed, stars ignited, planets coalesced. Life arose, consciousness bloomed. And now here you are, a fleeting ripple of awareness, gazing outward, asking whether the story continues. Already the asking is astonishing, because nothing in the laws of physics demanded that a creature should exist who wonders about forever. Yet here you are. The universe has grown a voice, and that voice is yours. Pause with that realization. Let it expand inside you. Because the synthesis is not about predicting the end. It is about noticing the miracle of now. If the universe ends in heat death, then this moment, with stars still burning, with galaxies still glittering, with minds still asking, is rare beyond measure. You live in the universe's luminous youth before the long night. That alone is extraordinary. If the universe ends in a big rip, torn apart by its own expansion, then this moment of coherence, of structure, of atoms still bound together is a fragile harmony, a balance before the violence. That alone is precious. If the universe ends in a big crunch, collapsing into fire and density, then this moment of space stretched wide, of galaxies scattered, is the breath between inhale and exhale. That alone is magnificent. And if the universe does not end, if it cycles or branches into multiverses, then this moment, your life, your breath, your question, is still unique, unrepeatable. That alone is enough. Do you see the pattern? The synthesis does not erase endings. It does not promise forever. It does not remove uncertainty. Instead, it reveals the wonder of being here at all, regardless of what comes. The universe may last forever, or it may not. But you are here now, in the brief window where forever is something you can imagine. That is the gift. Pause again. Let yourself feel the quiet weight of that thought. Because when you zoom out far enough, forever itself becomes less urgent. The precise ending, heat, death, rip, crunch, renewal, fades against the larger miracle of existence. The cosmos does not need to last forever to be vast. You do not need to last forever to matter. Synthesis is this. You do not need certainty to find meaning. You do not need eternity to find beauty. The evidence gives you a universe governed by laws, measurable, predictable. The counter case gives you mystery, possibility, humility. Together, they give you perspective. And perspective is enough. Think of yourself as a bridge. On one side, the cold precision of physics. On the other, the warmth of wonder. You stand in the middle, holding both. That is your role. That is your gift. Because perhaps the universe is not asking you to solve it. Perhaps it is asking you to witness it, to marvel at it, to reflect it back in questions, stories, songs. This too is forever. Not the forever of duration, but the forever of participation. The forever of being woven into the universe's fabric, not as an answer, but as a voice. Look upward one last time in this phase. See the stars glittering across the dark, each one temporary, each one burning its fuel, each one destined to fade, and yet together they make the sky beautiful. Impermanence does not erase beauty, it creates it. And so it is with the universe. It may last forever, it may not, but its beauty lies not in its endurance, but in its existence. The synthesis closes with this truth, that forever is not a promise of time, but a posture of wonder. To ask, to marvel, to live fully in the fleeting now, that is forever enough. You have gathered evidence, you have considered counter cases, you have woven them together into perspective, and now, just as you think you have reached the end, something deeper arrives, the unknown. Because the question, will the universe last forever, does not close with science or philosophy or metaphor. It opens, it fractures into more questions, each one larger than the last. Pause, let yourself feel that shift. The horizon is not closer, it is farther away than ever. Begin with the first open question. What is time really? You have treated it as a dimension, a line, a block. You have spoken of beginnings and endings, cycles and eternities. But do you know what time is? Not truly. Your clocks measure it, equations describe it, physics bends it, but its essence remains elusive. Does time emerge from entropy, from quantum processes, from consciousness itself? Could there be realities without time at all? If so, what would forever mean there? Already the question slips away. Now consider space. You imagine the universe as all that exists, but what if space itself is not complete? What if there are dimensions you cannot see, folded beyond perception? What if other universes exist beside ours, unreachable, unknowable? If space is larger than you think, then forever is larger too. Perhaps your universe ends, but reality does not. Perhaps forever stretches sideways as much as forward. Pause again, let the strangeness settle. Because the open loop is not about comfort. It is about stretching your mind beyond certainty into awe. Consider now the laws of physics themselves. You treat them as constants, gravity, light speed, quantum rules. But are they woven into reality, or are they emergent, contingent, fragile? Could universes exist with different laws entirely? Could ours transform into one of them? If so, then forever is not governed by one set of rules. Forever is a patchwork of possible realities, each with its own endings, its own silences, its own songs. Now ask the deepest question: why is there something rather than nothing? All your discussion, heat, death, big rip, cycles, multiverse, assumes existence itself. But why does existence exist? Why is there not only silence, but the possibility of silence? Why is there a universe to ask whether it lasts forever? This question has no evidence to answer it, no counter case to balance it. It is pure wonder, pure mystery, and it is perhaps the most important of all. A pause here, sit with it. Because the open loop is not resolution, it is surrender. It is letting the mind rest in what it cannot solve but can only marvel at. Now turn inward. What does forever mean to you personally? Not as physics, not as philosophy, but as a living being who knows you will end. Do you want the universe to last forever? If it did, what would that mean? Would you find comfort knowing existence never stops? Or would you feel unease knowing eternity can stretch into emptiness? And if the universe does not last forever, what then? Does that make your life smaller, or does it make it more luminous, more urgent, more precious? The open loop does not tell you. It only leaves you with the questions, because maybe forever is not an answer at all. Maybe forever is a mirror. When you ask about the universe, you are also asking about yourself. A pause once more. The galaxies are racing away. Expansion accelerates, entropy spreads, black holes wait, time bends, physics hums. And here you are, a finite spark in the middle of it all, daring to wonder. That is forever enough. And yet, the mystery continues. What if death is not ending but transformation? What if silence itself contains seeds of renewal? What if forever is not linear but layered with cycles beneath cycles, stories within stories? The open loop leaves you here, not with closure but with expansion. The horizon receding, the mystery deepening, the awe widening. You have followed the question as far as evidence can carry you. You have wandered through counter cases, cycled through metaphors, woven science with story. And still the question remains, luminous and unsolved. Will the universe last forever? The truth is, you do not know. Perhaps you cannot know. And yet that not knowing is not failure, it is gift. Because to stand at the edge of the cosmos, to look outward into silence, to feel the pull of forever, is itself extraordinary. To be a creature of atoms, briefly conscious, daring to wonder about eternity, that is already more than enough. Pause here, breathe. Feel the smallness of yourself and the vastness of what you are part of. The universe may end in silence, its stars burned out, its galaxies dissolved, its black holes evaporated into nothing. Heat, death, a final stillness stretching without change. Or it may end in violence, expansion ripping atoms apart, a big rip tearing the very fabric of existence. Or it may collapse, folding inward into a big crunch, a fire that consumes everything and perhaps births something new. Or it may cycle endlessly, universes reborn from the ashes of their predecessors. Or it may branch, bubbling into multiverses, each one carrying its own laws, its own fates, its own eternities. Or it may transform suddenly, a vacuum decay rewriting physics in an instant, a horizon of reality racing faster than light. Or it may surprise us entirely, in ways we cannot yet imagine. You do not know, you cannot know. But here is what you do know, you are here now. In the brief window when stars shine, when galaxies are visible, when questions can be asked. You are alive in the universe's moment of brilliance before whatever comes next. And that is astonishing. Pause again, feel the quiet miracle of it. You ask if the universe will last forever, but maybe forever is not the point. Maybe the point is that it exists at all, that there is something rather than nothing, that you, a small being of dust, can look outward and ask questions larger than yourself. Perhaps forever is not about time at all. Perhaps forever is about wonder. Because wonder does not end. Wonder is eternal as long as there are minds to feel it. And in this moment you are that mind. You are the place where the universe wonders about itself. That is forever enough. Think of it this way. When you gaze at the night sky, you are looking into the past. The light from stars took millions, even billions of years to reach you. In every photon, you are touching history. But you are also touching forever because in that gaze, past and present meet. When you breathe, the atoms in your lungs once burned in stars. You carry forever inside you in the dust of the cosmos, recycled and reborn. When you love, when you remember, when you imagine, you are extending yourself beyond the limits of your body into something larger. That too is forever. So maybe the universe does not need to last forever. Maybe forever is not a cosmic duration, but a human posture, the act of wonder, the embrace of mystery, the courage to live inside questions without answers. A pause here one last time, because the story does not end with certainty. It ends with openness. It ends with you lying in the quiet, drifting towards sleep, carrying the question like a lantern into the dark. Will the universe last forever? Perhaps, perhaps not. Perhaps the word forever itself is too small for what reality holds. But the asking is enough. The stars shine, the galaxies spin, the silence stretches, and you, fragile and finite, are part of it all.